The last topic of abstract data type that we're going to talk about is Q. Earlier, we talked about what an abstract data type is. An abstract data type is about specification and implementation. And we talk about a list, a general list, a list, a linked list, a double linked list, a circular double linked list, and so on and so forth. We then talk about stack. Now we're going to look at another abstract data type called the queue. A queue is an ordered list which all insertions take place all at one end, the rear, while all the deletion take place at the other end, which we call the front. Different from the stack. The queue, where stack is actually you push and pop at the same end. Here, there are two, the rear and the front. And different from the stack, which is last in, first out, a queue is what we call a FIFO, or is the first in, first out. This is an example when you're standing inside a queue to get onto a bus or to be served at a bank. The queue, if you enter the queue, it's first come, first served. So if you are there first, then you will be actually first one to be out as well. The later that you come, the later will be out, or the later will be served. So very similar to a stack, the queue has two important operations. One is called an enqueue, and the other is called a dequeue. Enqueue inserts an element at the end of the list, while dequeue deletes the element at the start of the list. Here we can see that we also have things like create, add an item, you delete what's a front, what is empty queue. And here is a schematic of a queue. You will enqueue it, an item of a particular queue. Then you would dequeue it, and you would take out the item out, whatever the item is in front of the queue. So you could see this. We could implement this as an array. So if we do that, then what we have is a queue, a front, 5, and the queue of the rear is 1. So inside the queue, we have elements 5, 2, 7, 1. If we have one more item, for example, in this case here, the initial state is 2 and 4. If you want to insert an element or enqueue of 1, we can see that because we are constrained by the array, the shoeboxes, what you could do is you could have a wraparound. Or simply put, you will see a phenomena if you use an array implementation of a queue, is that it will crawl the memory. As you enqueue and dequeue and enqueue and dequeue, you can see that the memory usage will be slowly moving across your memory. This may not be a good thing because you want to somehow manage your memory, at a certain particular place if it's at all possible, and avoid moving a lot of things. So if you use an array to implement your enqueue and dequeue, which is absolutely okay, and it will be correct. However, your complexity of doing some of the enqueue and dequeue may be different. Or there could be some other conditions that you have to check. For example, if you continue to crawl your memory, there will be a last item of the memory that you cannot crawl beyond that, right? Then what you need to do is maybe reset and copy that queue to the front of the memory. So you can see that we can insert another element at the rear, which is element 3. And when you DQ, you could actually return 2 and the 4 and then 1 and so on and so forth. Now, the application of this, there are many applications that will use a queue. For example, when you print to a printer, and there are many people may print at the same time to a printer, the printer actually has a queue, so it will perform what we call a first come, first served. Your job of printing a paper or a page will be determined by the order that it is received. So if you are inserted into the queue first, then it will be the first to be served and to be printed. Airline controller, on the other hand, also has a queue. So when the airplane actually comes into an airport ready to land, the airline controller will tell you, oh, you're in the queue. Okay, you're behind this particular jet or flight, so you need to actually land after this particular flight has landed. And in banks, we also see the banking queue. So when you go into the bank, want to be served, they'll ask you to line up. And bus queue, restaurant queue, and so on and so forth. So what we could say is this: although we could use specification of a queue that is fairly similar to what a stack is, the physical model can be implemented by using a linear array, okay? Or you could actually use a linked list to implement a queue as well, okay? So you could use, in this case, a circular array with the front and the rear indicate a Boolean variable to indicate whether it's full or empty, and a circular array with the front and the rear indices and an integer variable counting the number of entries so that you know when the array is full or not. So you should know how to define what a queue is and what operation can be done in a queue, and list at least 4 different implementations of a queue. As I said before, you could use an array, you could use a circular array, you could use a linked list, and you could use a circular linked list or double circular linked list to implement a queue. To summarize the abstract data type, what we see here is this: the definition of the queue and how you implement it could be very different. I only have one set of specification or definition for a queue, but I might have 4 different implementation of the queue depending on the underlying data structure that I use to implement this queue. And furthermore, because the underlying data structure is different, your algorithm will be different, and your algorithm complexity will also be affected, and they will be different as well. Is there one implementation of a queue that is almost always better than others in a computer? What is your answer?